June 2007 Core 3, the last question, question 8, so expect it to be a little bit tough here. First one here, loads of people couldn't cope with this. The integral of sec squared x is in the formula book, and it's one you should know. It is just tan x. 1 mark, no more work than that. Part B was done pretty well. We've got to do a quotient rule. So the top bit is cos x, the bottom bit is sin x. Differentiate this one, cos goes to minus sine. Differentiate this one, sine goes to cos. And the rule for dy by dx is that it is v du dx, so I've got minus sine squared x, take away u dv dx, minus cos squared x, all over v squared, all over sine x all squared, or sine squared x. You can see here I've got a factor of minus 1 on the top, and then I can put sine squared x plus cos squared x, which we know is equal to 1. So we've got minus 1 over sine squared x, and sine squared x, of course, on the bottom is the same as cosec squared x. And we got the minus in there as well. So there's part B. Part C, I didn't like people trying to do the proof, trying to merge all these things together, but of course the recommended way is to start with the left-hand side, which is the tan x plus the cot x all squared, and now work with it until we get the right-hand side. So first things first, I'm going to square both sides. I'm going to square this side, multiplying it all out. Now, tan squared is exactly the same as sec squared x minus 1, isn't it? That's one of your formulas, you know. And cot squared is the same as cosec squared x, take away 1. And what's this? This is 2 times tan x over tan x, because cot is tan at the bottom. They cancel out, so we've got plus 2 on the end. So we've got sec squared x plus cosec squared x, and which equals the right-hand side. And so we've proved it. Which leaves us then with the last part. And all what we've done before has been trying to set us up to do this last part now. We've actually got to do the integral of tan x plus cot x all squared. Well, let's not even bother doing that. We know that that's going to be the same as sec squared x plus cosec squared x. We've already done that. And both of these bits have already been set up in what we've done before. Part A, we actually integrate sec squared x, and the integrate of sec squared x was tan x. But don't get flustered with this bit here as well. We've already done this as well. Look, we differentiated cos over sine, and that gave us minus cosec squared x. So when we integrate this, we're going to get back to here again. So we've got minus cos x over sine x. Could even write cot x there if you wanted to. And the values you're trying to put in there are 1 and 0.5. As long as you're in radians mode now, drop those two things in and find out the answer. I think it was 2.2, but that's just from memory.